Manufacturing Matters is an MFG Radio Network production brought to you by GIE Media's Manufacturing Group as industry experts take deep dives into the latest manufacturing matters, whether it's new innovations, products, technologies, and emerging markets that help you understand better why manufacturing matters to you and also to the top companies in the medical, aerospace, defense, and electric vehicle manufacturing industries.
I'm Jake Kaufman, the GIE Media's Manufacturing Group Managing Editor. We are happy to be joined today by Visual Components as they will discuss the latest automation products that will help you get the most out of your operations and streamline your manufacturing process while also increasing your productivity. We'd like to thank Visual Components for sponsoring today's discussion. They were founded by a team of simulation experts with 25 years in business. Visual Components is a pioneer in 3D manufacturing simulation. Visual Components is a trusted technology partner with more than 2,400 leading brands and 40 partners globally, offering machine builders, system integrators, and manufacturers a simple, quick, and cost-effective solution to design and simulate production processes and robot offline programming technology for fast, accurate, and error-free programming of industrial robots. Today's panelist is Graham Locke, the Director of Business Development at Visual Components. Locke is a seasoned professional with more than a decade of experience dedicated to understanding and addressing customer challenges. Throughout his career, Graham has excelled in developing custom solutions tailored to individual needs and goals, fostering enduring relationships within Visual Components user community. However, without any further ado, let's get to that discussion. Graham, thank you so much for joining us today.
Yeah, not a problem. Glad to be here.
Awesome. So the first question then that I have for you, sir, is why should simulation be used while incorporating automation in manufacturing?
Well, automation is a huge part of what's going on today, with the challenges from the last couple of years, COVID, supply chain, everybody wants to automate, and everybody says, ooh, let's do this. Ooh, robot here. Ooh, AGV here. And a lot of times what we find, automation for the sake of automation is a mistake. It's in the wrong spot. It's in the wrong place. It's applied in a way it shouldn't be. If you've got a line with 10 processes, you could make that third process the best process ever, most efficient it will ever be, but you still might not see any increase in production coming off the rest of the line because the rest of it isn't balanced. You focus on micro and lose kind of that big picture. So what simulation does is as people get into that, let's automate, let's embrace technology, let's continue to move forward with tools and equipment and things like that. Knowing what you're going to get is a huge part of it. Knowing and recognizing that manufacturing is a living, breathing, like complex system, and everything you do has a consequence. And when you can take that step back and in a digital safe environment, make all the mistakes, do all the things wrong, test all the what ifs, and then when you get to the end of the day, your investments, your optimization, your processes, everything is that much better.
Awesome. And we got the first little bit of results from our poll question, and this is hard to believe, but we literally have 25% of people involved in aerospace manufacturing, 25% of people in medical, 25 in defense, and another 25 in general manufacturing. Yeah. So I don't know how it came to be that clear of a disparity between all three, or all four, but so no need to worry about gearing the conversation towards any single industry because it looks like everyone is involved at the moment. So the next question I have for you, Graham, then is how can automation improve your factory layout and also the design?
Well, like I was saying, and I think one of the most important things that people need to think about at first that a lot of people don't even consider is literally floor space. What goes in that facility? What goes on in those four walls? What can you get in there? The more you can get in there, the more you can do, the more efficient those processes are, the better off you're going to be. I was on site at a customer years ago, and they took me to the facility, and I was looking around, and I looked over at a wall, and I was like, well, what happened there? And they had literally knocked out part of the wall and had like a lean-to built out the side of it because nobody had bothered to actually see if the system would fit within those 4 walls. And like, yeah, we don't like to talk about that. And I'm like, oh, obviously you don't.
Yeah.
But that's again one of those things where just from the very beginning and seeing where it fits in within that footprint, I mean, you can really get a good feel for what you have to work with. You know, and then when it comes to simulation, it's not just for robots. And people think that, oh, I don't use robots, I don't need to simulate, but people are as important, if not more important than anything else, because they're still doing the majority of your tasks. So being able to understand, you know, how all of your different resources work together, you know, your people, your robots, your you know, stocking your dunnage, your kitting areas, all of those things are great, but like again, they all need to work together, like one you know, discipline or part after the next. And when you again can take a step back and see what that interaction looks like, when you take a look at that manufacturing process, whether it's people or robots and how they interact together and machine resources, it's huge. You know, if I can, you know, reduce my number of human resources in one area by 2, I'm not eliminating jobs. I'm reallocating and putting them somewhere else. Again, it's for that best possible distribution of what you have to work with to really take the most advantage of what you have. And you know, it's greenfield. You know, you're brand new. You're laying something out. What's that look like? But then also in you know, process improvement and continuous improvement. People still need to be able to big picture everything and look at it and see how it all works together for that optimization.
Thank you, Graham. So we do have a question from the audience. Shavlav wants to know, in what ways do you see AI being integrated into the manufacturing for the aerospace industry? Now, obviously, I feel like automation and AI end up kind of going hand in hand in a lot of these discussions. So, yeah, well, how do you see artificial intelligence kind of working its way in?
It's in the early stages. I'm not gonna lie. This isn't like Chat GTP where it's like write me an email, right? Like like manufacturing and processes. It's a little bit more complicated than that. And what makes it even more so is that, you know, everybody's best practices might be different. I can have five aerospace companies and they all do things a little bit different. And that's where it's important to not just say, well, AI told me to do it, but to really like be able to direct it to start making some of those decisions. Now, whether we get to the point of, you know, you open your computer and you're like, computer, make me a layout that produces X. Like, I don't know. We're not there yet. We're still using, you know, people to make those decisions. But, you know, I do see AI, you know, when you're making switches to automation, when you're, you know, want to do some reach studies, when you want to do some time studies, when you want to do stuff like that, I see AI being able to, you know, recommend certain things to be able to steer you in the right direction. And then through that learning, understanding individual best practices, kind of start to develop, you know, individual type solutions. But we're a long ways from there. It starting, but it's in that type of thing. It's going to be a couple of years probably.
I know we've seen a lot of people have preventative maintenance that is set up through an AI, and that's one of those, you know, right in line with what you're saying, where it's going to help you be the most efficient at your job. Awesome. Yeah. So the next question we have is, what steps should be followed in the plant layout design process when incorporating automation?
I think that the most important part is kind of like I said, understanding what you have, right? Like really sitting there. Very rarely can somebody walk into a plant, take a look at a production line and be like, oh, there's the problem right there. It's too big. There's moving pieces. It's complex. And without being able to take a step back and look at data And that's a huge thing that the simulation environment provides you is, there's a lot of people out in the space that do this stuff. You have animation, pretty pictures, it'll get you a sale. You have simulation, data driven numbers. It could be two-dimensional stuff flying around your screen. And then you get emulation, which is signals and controls, things like that. But when you try and take them and put them all together, really being able to understand what you have and then attaching numbers and data and values and utilizations and things like that to it. I mean, that's where you really get into the area of data-driven decisions, of really getting your biggest bang for the buck, really being able to kind of sit there and say, if I do this, I know I'm going to get this. We deal with a lot of customers that do, high mix, low volume, or just in time manufacturing. Yeah. And it's always challenging in those spaces. And one of the great things to do is, in a manufacturing environment and through simulation, what you got, what you make. If you've got a broadcast, if you've got a recipe for production, if you've got whatever it is, you can actually use that to drive the simulation. Say, had I done this different, had we moved this here, had we incorporated this new process, what would we have got? And then you can actually, from a very high level, compare apples to apples. It's not just in a perfect simulation world, we can make this. Well, the real world's not perfect. So, we like to be able to take that step back, to understand the robots, the machines, the people, the processes, shipping and receiving. I mean, we've done simulations where they were hitting a customer was missing their delivery numbers, and they couldn't figure out. They looked at all their steps. They said we don't know. We can't figure it out. They just weren't getting their build pallets back from when they delivered them. It was shipping. They didn't have enough trucks. The process was beautiful.
Yeah.
But they had to look beyond the walls. So again, really being able to use a tool where you can understand even before you get in the door to after you leave the door and everything in between, that really sets you up to start using that data to evaluate and start saying what if and making those decisions.
Awesome. So this is obviously something that I know Visual Components is known for, but if you could kind of explain what robot offline programming is for the audience.
Yeah. Robot offline programming. All right. So everybody's excited about robots. Robots this. I just watched a video yesterday of a kung fu robot that was jumping and kicking, and it was really cool. But we've also talked to companies where they order robots and then they never unwrap them because they don't know what to do with them. They don't have the time to, put them in the line and then figure them out, and production can't be down, and they run into these problems of it. It sounds great. It looks good on paper, but the actual application of it and really inserting it into that process becomes challenging, especially in those high mix, low volume environments like I was talking about, where programs change, sequences change. There's always switchover, and to be able to take that robot and to be able to program it offline, like we're not in production environment, we're not on the space, we're not on the floor, we don't have a teach pendant in our hands. We can do that ahead of time in a safe space and literally do it offline. Right. We're still online, but off the production line. Being able to do that will decrease downtime. It'll increase accuracies. It will, help with product changeovers, things like that. Because again, you're doing this all proactively ahead of time, not reactively. We're not staying up late at night. We're not doing it between, second and third shift or whatever. We're really able to have these loaded, ready to go, thought out, calibrated, and everything else. We just push that down to the floor. We'll do a couple little quick touch-up points and be ready to go. We see integrators, being able to do that, before integration. We're able to see, customers do that as they change robots as they, like you said, add automation to their processes. We're able to see them have that ready to go. They put it online. They spend a day fixing it up, touching it up, and they're good to go. Instead of weeks of time for these complex processes, clicks of a mouse, CAD to path, you're creating hundreds of points with a couple of clicks and you're good to go. I mean, it's ideal. It's a dream scenario for guys doing the programming because it takes all that pressure off and really allows them to put out the best programs, not just ones that work, because as soon as they work, your hands off. And we find in live situations, quality sometimes gets sacrificed for speed.
Okay. So then when you are doing this robot offline programming, is it something where like after 2 years you should go back in and reprogram them? Is there like some sort of a maintenance that you guys have to do, or is it once they're set, they're good to go?
They should be generally good to go. I mean, there's obviously robotic maintenance, there's tolerances, there's tightening stuff up after a while. But I mean, imagine, 2 years in, you're a little bit off and you have to go in and try and figure out where you're off with a teach pendant. And you've got 1,000 points that you're hitting. I mean, it really becomes very challenging to see where you're at. Just like we can take all these taught robot sequences and post process them out into the actual robots, we can actually record those sequences and put them in the software. And you can actually see the deviations from sequence 1 and sequence 2 and kind of see where you're off and where you might not be hitting and see any differences between, first run and run 5,000,075, whatever you happen to be at that time.
Okay. And then how easy is it to add other robots to an operation that has been offline programmed?
Oh, it can be very easy. And a lot of robot brands out there have their robot software. And they're all amazing. They do a great job for that robot and that part. Right. But when you've got multiple robots, you've got multiple stations, you've got multiple operations, you've got people that are getting in there, maybe in between. You've got additional things going on, you really start to lose stuff. Then you've got a bunch of individual cells not aligned. Right. So, when we do it, regardless of the brand, doesn't matter, regardless of the CAD you're using to do your programming, don't matter what your models are in. It really allows you a lot of flexibility to, again, you've got a yellow robot and then you want an orange robot and then you want a white robot and you can swap them in and out by saying change robot and click the new model and it literally just switch them out for you. Very quick, very easy, very simple to do. Robot neutral. I think we're up to like 70 robot manufacturers. I think there's close to 3,000 robots in our library. So again, you really are never going to be short robots to use or things to try out. But again, very simple, very easy. When we build simulations, right? And a lot of people, even when they talk about simulation, adding robots, it's complex and I don't want to teach it because as soon as I teach it, something's going to change and then I have to start from zero. When we do capturing concepts and designs and proof of throughputs and things like that, we don't actually teach the robot. We say, pick it up from A, put it at B, and use this TCP. And the robot will do all that stuff on its own, capturing concepts and ideas within manufacturer tolerances, speeds, joint limits, things like that. So you're not going to do anything in a simulation environment you can't do in the real world. But again, put in the effort, put in the time, put in the resources when it's necessary and when it's beneficial. Capturing concepts and design, we're just seeing if it'll reach. We're seeing if the idea is valid. So again, when we do it, there's a lot of on-the-fly programming that we do behind the scenes. Pick it up, machine 10, put it here, add this, do this assembly, move it over here, and then put it on an outbound conveyor. And that's all done automatically for you. You move stuff around, change stuff, change your underarm tooling. But again, that very early on in the capture concept and idea phase of that operation where you're using automation and robots makes things much easier. And then at the end of the day, when it works, when it's sold, when the throughput's been proven, when the cycle times and the accuracies are good, then take the time to do the programming. And we haven't even gotten the robot delivered yet. So again, we're being proactive. We're getting ahead of it. We're making it easier for you to get to that stage, and then providing the tools for you to actually get down to that like granular level in the same platform, the same environment.
Awesome. Thank you, Graham. So the next question that I have for you seems like a very simple and easy one, but I'm thinking if we kind of like expand on maybe some examples, it'll definitely help out with the audience. But how can robot programming help improve production efficiency?
Again, the downtime is the equivalent of, it's like a lot more than 4 letters, but it might as well be a 4-letter word. I mean, downtime is the devil. You don't want it. You don't want to see it. You want to be able to, do changeovers, do switchovers, do product, whatever. And certain industries, it makes more sense than others. You're in automotive and you've got to run for 3 or 4 years and not much changes. Okay. But again, there are other environments where it changes constantly, and to be able to do it offline, to be able to get ahead of things, to be able to do that pre-planning, to be able to, again, allocate resources somewhere else. We're not just talking about people on the floors. We're talking about that guy that used to spend 2 weeks online with a Dependent doing something. If it takes him an afternoon to do that job, you've reduced that time by 90%. Resource somewhere else. And I mean, and again, it's not just those processes, but it's, what simulation brings to the big picture of manufacturing is being able to, really take advantage of those savings and apply them somewhere else. And that's in production, that's in engineering, that's in sales, that's in controls, that's in all these different areas where the more you do, early on, the easier it is, to execute, to do those changeovers, to avoid the downtimes, to, make the necessary changes, and again, feel confident in them, and to know they're optimized, not just that they work. Right. We see people all the time where it's like, our production goal is X, and they hit X and they're done. They hit their target.
Yeah.
That doesn't mean it's optimized, right? And again, when time becomes that limiting factor, you're sacrificing a lot of that to maybe crunch it down into certain windows. Deadlines are a killer. Downtime's a killer. You can't do it. You got to push. You got to give up something somewhere. So, again, by doing it ahead of time, by being proactive, by having that better big picture understanding, by having data to support it, by not constantly running around and putting out fires. Nobody wants to be a firefighter. I mean, the amount of time and effort and money people spend in a reactionary phase of manufacturing and production is crazy to me, especially when you can negate some of that by again doing it in a safe space. Make your mistakes there, break everything there. It's pixels. It's not a big deal. And then, you're good to go when it comes to your actual process.
Not to mention too, I think the predictability that you get once a robot is programmed is nice, knowing I'm going to make 200 pieces during this shift because that's what this robot can do. You don't have to worry about it getting tired or anything like that.
Provided everything else around it works.
Correct. Yes.
Again, like I said, you look at that one process and that one cell and you're like, ideally, this is what I'm going to get. But then you ignored the process before and the process after, and you're still no better off. So yes, you're right. And again, a lot of times, we even offer a virtual reality component to these simulations, right?
Mhm.
So once you build it, we've seen people take these VR environments to like Kaizen events, and they'll actually have the line workers put on the helmet, say, "Here's your station, here's your process, here's where everything is. What do you think?" And
Yeah.
again, it's not just teaching a robot, but it's listening to somebody who does it every day. That
Right.
you have every level of employee and every piece of your process that's invested in it, that's able to improve it. And again, it goes live and it's already optimized. You're not doing things after the fact. You're not playing catch up. You're not trying to plug holes and figure out how to make this better because that and that it just takes a lot of that stress out of it, and honestly it just lets you sleep better at night because you know what you're going to get.
Awesome. Thank you, Graham. So we do have another audience question, as Diego would want to know, would it make sense to focus initially on fostering a lean mindset across the company and then proceed with investments in automation?
Absolutely, I think so. Enough cannot be said about being able to understand your current process. If your process isn't optimized right now, there's a lack of I don't want to say like ability to do it, but something's missing. And
Mm,
if you just start throwing automation at it, there's going to be something that's going to get missed, and it's not going to be a good experience, right?
mhm.
The optimization and automation should go hand in hand, but only if you really understand that big picture. And again, what every change is going to mean for every other station and every other process. Once you have that big picture, once you have that lean, once you figure that out, once you've got that data to back it up, and you know your bottlenecks and you know all of the different pieces in it, then you can start to say, if I did this here, then what? And again, do it in a safe space. So when you do make those CapEx investments, when you do talk about floor space, when you do talk about 3 machines versus 4, 2 people versus 3, putting one robot on a track versus 2 robots, what do all those changes mean? What's that going to mean for my bottom line?
Mhm.
Understanding the big picture, not just that one cell. So absolutely, I am a big advocate and proponent for lean and for understanding that process and understanding the big picture, and then when you've got a handle on that, really getting down to your biggest bang for the buck, the right investment, the right place, the right time.
Okay. Diego wants to know, why do you think companies prioritize automation before building a lean culture?
It's a buzzword. It's a buzz. It's an industry 4.0. It's a digital twin. It's all of these things where if you ask 10 people what industry 4.0 is, you're going to get 10 different answers. If you say
Mhm.
what's a digital twin, I've had people say, well, that's a digital twin because it's on a screen, and that's simulation, but it's not a digital twin. So people get all excited. Like I said, the people that buy the robots but don't know how to deploy them,
Yeah.
people that buy AGVs and AMRs but then can't figure out how to do fleet management, and it might not even be more efficient. So yeah, it's people getting a little bit excited, people thinking that they can skip steps and accelerate the process. And don't get me wrong, I love excitement and enthusiasm,
Mhm.
but I like the engaged, intelligent decision making a little bit more. And the tools that allow you to get there are simulation and really doing it in that safe digital space.
And it seems to, not to use this word as it is used in the automation, but it's a collaborative effort. If you don't have, as people
Mhm.
say, the shop floor to the top floor invested
Yeah.
in it, if you don't have their input, it's not going to end up working out for you.
Very, very rarely are the guys that design the process the guys that do the process.
Right.
And,
Yeah.
and they're never the guy that approves the process,
Yes.
that signs the check. So, when you start to engage at every level, and then simulation becomes more. It's a platform. It's a cradle to grave, start to finish, concepts and ideas. Is this even worth pursuing? Right? Think about how much time is wasted in meetings where it takes 5 meetings for everybody to get on the same page. There's a comic strip out there. It was like, what was proposed, what was billed, what was documented. This is this tire swing. I love it. Look it up. Manufacturing tire swing or something. And nothing is this. It is all over the board. And that really, is kind of true in manufacturing because everybody's kind of using a different tool. Everybody's kind of in their own space. Everybody's siloed, focusing on what they're focusing on, and the tools aren't the same. So when you are able to take a platform and do concepting, to do applications, to do robot stuff, to do control, to do all of those things and have people on the same page with the same data, it really does improve collaboration internally. That's why a lot of integrators are big users of simulation because it's different every day. Right. We're seeing a lot of end users that used to use integrators and consultants say, why am I farming this out? Why am I letting somebody else control my destiny? Why am I trusting them that when it's my job, my process, my product, right? So owning your own process is another big part of simulation where you really control it. You use your knowledge, your experience, your understanding of your product within the industry to make it better, to improve on things, to do it in a more efficient way, to drop money to that bottom line, because that's what it's all about. And by being able to control that, it really makes things a whole lot easier for these end users. And again, we are seeing that more. The last couple of years, I always love telling people it's not like it was back in the day, right? Big companies ate small companies.
Yeah.
I don't want to compete. I'm just going to buy out. I don't care. Right. That's not how it works anymore. It's the fast companies that eat the slow companies. And we saw, after COVID, a whole big, like, we've got to do things different. We're gonna, and then it's over. And now people are like, well, we kind of got through it. Do we really need to? And with the uncertainty on certain things within, the American manufacturing environment, it's like, we're gonna, and then, we made it through. And those companies that continue to, we're too busy. Well, now's the perfect time to do it, right?
Yeah.
When you're slow, you're out of luck, right?
Yeah.
And so we like to see people adopt. We like to see people try and look forward. We try and look for those people to see technically relevant. I mean, there's large companies out there that are still using Excels and PowerPoints, and that's how they design their processes. It worked in the past, and it's kind of working now. So what? And it's just like that's one way, but it's far from the most efficient and the best when it comes to big picture, real understanding, and being confident in that data.
Awesome. Thank you, Graham. So the next question I have concerns virtual commissioning. What do you believe what are the processes and the benefits of using virtual commissioning?
If you ask any controls engineer, they're always getting the short end of the stick, man. Like installation was late, delivery was late, setup was late, lines got to be on in 48 hours, go. And again, that's not a space anybody wants to be on, because the second it works, it's hands off, fingers crossed, let's hope it works. And when you talk about that controls engineering and being able to be in that space, it's very similar to the robot programming. If you have that digital environment that you can test all your controls on ahead of time, ahead of equipment, ahead of installation, and ahead of setup, I mean, again, that comes, it changes from 48 hours straight to an afternoon and it's optimized. And
Mhm.
I mean, again, that's a space people would much rather be in. It also kind of drives you to really even have that, I would say, the highest level of understanding of simulation, right? You can plug
Mhm.
some things together, you can make some things move through a simulation, but like by the time you put the controls in for conveyor motors and gates and curtains and different things, you have that dialed in. You know that process. You have that understanding at that level. And then there's a lot of companies out there that do it. But once you've built the simulation, once you program the robots, we have direct connections to WinMod and Simit and Beckoff and Mitsubishi, and we can do anybody through an OPC which is just a third party handshake, and we fool that PLC into thinking it's running the real equipment because all the signals are there, the processes are there, everything it's waiting for is provided by that simulation environment. It's dumb. The simulation doesn't know what to do. It's waiting for the PLC to tell it what to do. We've done labs where we sit there and in the simulation, a box gets to a routing conveyor. Then it just sits there. Then we've got a scanner gun in the lab and we scan different barcodes in the lab and it does the routing based on whatever we scan. It's real time. It's waiting for the signals to tell it what to do. So when you get into that space of being able to create that layout with those signals, control that logic and validate your systems and stuff, again, optimized, on time, no headaches, hassle free, and it sets you up. If you have that for that controls validation, you have a scenario where you can do a true digital twin, where you can take signals from the real world. If you're able to collect those signals, you can import those into the simulation and run a real time, parallel, 100% live digital twin of your manufacturing environment. You could check on a factory from anywhere in the world. That's digital twin. That is a real time, running at the same time, digital twin. Not a simulation of it, not something in a virtual space, but a one for one. And that's what we're looking for. And if you get to that level, you have mastered your process. You know what's going on. It is tuned up. It is ready to go. And you really don't have a care in the world. I mean, those users are amazing. They're high level, thinking ahead, planning it all out. Nothing catches them by surprise. They're ready to go because they've thought it out. They've analyzed it and they've applied all the things they need to in that space proactively. And that's, I mean, we couldn't be more excited when people get into that area.
Awesome. Thank you, Graham. So we do have time for a few more questions from the audience.
Yeah,
so you
of
guys
course.
can ask at the bottom of your Zoom screen in the Q&A box or even in the chat. But if we wanted to ask you right now, how can automation be customized with customer engagement? Obviously, that was something you had touched on throughout this entire. Do you have a few examples that are your favorites potentially, maybe, of how you've been able to work with the customer and make sure that they got everything they wanted?
I got a lot of NDAs out there, so
Yeah.
I don't know that I go into specific customers, but I will say this about simulation and customization, right? You said right off the top, we've got people in different industries, right? And different processes and different applications and best rules and things like that. So, when you get into that simulation space, the last thing you want to do is say, I know it shows this, but imagine it's doing this. Because that simulation tool is kind of rigid and doesn't allow you to really show your process. And at that point, you're losing something, right? So, I said we're robot neutral. We're CAD neutral. You want to bring in a part in SolidWorks. You want to bring a part in Creo. You want to bring in a part in whatever any different format. You can actually have all that CAD in the same layout and use that CAD for your simulations. and by being neutral like that, it really kind of opens you up to all of the different applications. We had a customer, I sold a customer last year, a car wash.
Oh, okay. Yeah.
They used our paint application to adjust the spray, the bells, the whatever, so they could run different car bodies through to check coverages. So they could optimize the layout of the sprays in the car wash. We were used by in Colorado, an agricultural manufacturer to help with some of their processes. A lot of those tools out there are very kind of out of the box. They're rigid. You get what you get. We kind of subscribe to a show what you mean and mean what you show. So we've got actually an open API for non-technical people. You can get in behind the scenes of all of our components. You can build your own. You can write your own rules. You can develop applications on top of the software that do things your way, that are kind of like little wizards for your processes. We really think the tool should work for you, and not the other way around, where you're working to make the tool work. It should be so that it's able to be customized for whatever that application is for you, to really, again, visualize that process and write the rules so the data is valid, the data is relevant, the data makes sense based on what it is you're doing. And if you don't have that flexibility and freedom to do those customizations, it shows this, it means this, the numbers are this, but it's actually this, then again, what's the point? You might as well be using an Excel sheet to do it, because you're still, again, that far away from attaching the animation, simulation, emulation, all in that same space. So yeah, customize it. Different applications were defense, automotive, integrators, automotive, all over the place. It really doesn't matter. If you make something, if you do something, if you only have people, we're not even talking automation. If all you've got is people, there's still a lot of value in simulation for resource process planning and where people are going to be and what they're going to do and where that dunnage is going to be and all of those different things that go into human processes and being able to put those numbers on a curve and efficiencies and seeing what that looks like. So yes, it should be customizable. If it's not, there's better options out there. So you can really, again, show exactly what you mean.
Oh, thank you, Graham. So it looks like Jason out in the audience wants to know, what can we look forward to seeing from Visual Components at Automate?
I wish you had said Automatica, because I've got a lot of announcements at Automatica. But we are going to be at Automate in Detroit next month, whenever it is, May, I think. We're going to have that interactive VR where you're going to be able to actually, see some layouts, see some stuff moving around. We're going to be showing how you can do CAD to path on robots, where you're literally just click on like the hood of a car and you generate 500 points with a click of a mouse based on a couple of fields that you enter. We're going to be showing a lot of things like that. We can walk through, the cobots. We can walk through, human interaction in robotic cells with safety and all of those things, because again, it's part of the process. You got to simulate it. So we do light curtains and things like that. At Automatica, we're going to announce our newest version, and when we'll talk about some of the things that are coming out in that. We have a couple of partnerships to announce at Automatica, people that we're working with that will enhance the functionality of what Visual Components provides, not by claiming to be experts at any one thing, but by finding other experts out there and leveraging their expertise to make our product better. We're not the experts, guys. We're a platform for simulation, you're the experts, and we're not ever going to be in a space to tell you how to do your job. That's again not what simulation is. That's for you to figure out. That's what that tool is for. But we'll be there. We'll be able to have all those conversations. We might, as we get a little bit closer, we might be able to kind of give you a preview of some of those maybe announcements at Automatica. But automated, it's pretty standard stuff for us. And by standard, I mean pretty exciting when it comes to simulation.
Awesome. So that just about wraps things up today. If anyone has any last minute questions, we can get them in now. But if not, I would like to thank Visual Components one last time for sponsoring today's discussion. And obviously a massive thank you to Graham Locke, the Director of Business Development at Visual Components. Thank you so much for your time and expertise, Graham. And I hope you get to enjoy some sunshine today.
That's the plan. That is the plan. I appreciate being here. Like you said up top, I've been in this game for a little bit now. I've kind of seen simulation go from novelty to almost to a necessity.
Yeah.
And it really is exciting being able to help companies that, again, want to take that step, want to make those changes, want to take advantage of what's out there to make their process better, to add to their bottom line, and let them get sleep at night. I mean, that's really what it's here for. And we love finding those companies and working with them. It's a partnership, and we're there every step of the way. So again, even if it's not us, everybody should be looking into simulation in one area or another. Pros and cons with everybody, but again, it is, as the years go and as things like AI get added and as manufacturing continues to evolve and change, you really need something there that's going to be able to grow and scale with you. And simulation is an amazing way to understand that, to be prepared for it, and be ready to meet those challenges head on.
Awesome. Thank you so much, Graham. Once again, have a great rest of your day.
Have a good one. Thank you.
You can listen to all of our episodes of Manufacturing Matters and Lunch and Learn podcast from the MFG Radio Network on Spotify, Apple Music, and on our websites, todaysmedicaldevelopments.com, aerospacemanufacturinganddesign.com, defenseandmunitions.com, and evdesignandmanufacturing.com.